Hello guys, today we are going to calculate the seismic mass of the building. For that, we have the material properties of concrete, brick, plaster, finishes, unit weight. We get it from the Eurocode, um, Eurocode 1. You might see it here. Eurocode 1, 1991. Yes, we get it from here. We have the design properties over here. Yeah, here is we have the density. We have everything for live load, late load. We have everything. If we have the density, then we know the volume, then we can calculate the uh, force weight of the element. Let's go to further process. This is our unit weight. Then after we have the live load calculation from which table 1991 Eurocode 2002 table 6.2. Let's go to 6.2 table. Look, table 6.2. It is a little bit high top. 6.2 to 1. Yeah, we have calculate taken the value from here. Yeah, we have taken the value from here. 6.2. Where is 6? Okay, yes, here is 6.2. We have live load, input load for floor. The live load is 1.1522. From here we take the input load, live load. Then we go. Then after we calculate the date load, calculation we did it. We have the unit weight, length, breadth, and height. We get the Newton. By this we calculate the total load of phosphorus, second floor, roof, and we calculate the imposed load. We have the kilometer per meter square 2.5 for the car parking. Then we multiply by area, which we get from the AutoCAD. Then get the weight. So similarly, we calculate for everyone and total report. And we need to have the seismic marks. For the seismic marks, we have the relation G plus delta plus mu Q. We have U 0.3, but with this we get this one from Eurocode 1998, 2000. 1998 we get from this it with the code yeah, this 1990 from the Eurocode 1990 2002. We have the basic structure design, and from here our area lies on category B. And category is office area 03515052. You can see it in this part also. Okay, I will show you here. Yeah. Is this one here? This one is not here. From here we get the value. From there we get the value of get the value of and 0.2. Yeah, from here we get the value that is 0, that is 0, that's 0.503. Yeah, 3, and, and we multiply it. That something EI. EI, that means 5 into something US. We get the U2I, which is 0.3. Then we need to have the value of phi. The value of phi will determine from Eurocode 8, page number 52. Look, we can go Eurocode 8, page number 52. Page number 52. Yeah, we can UI is equal to phi into U2I. For this, our category tries to A to C. But it is category A. Then we have 1 into 0.3. And building categories we have identified from table 6.1. Table 6.1, I can show you this one. We have in table uh, 6.1. Yeah, table 6.1, and it is our area for domestic and residential activities. From here we calculate, we get the all the value. Then we go to and we calculate the value, like roof is equal to 17.40. Dead load and live load we have 7.24, and we multiply live load into 0.3, and we get the value G plus V Q. And then if we change in the mass, we change the mass dividing by 9.81. I can show you, like with the mass dividing by 9.81, we get the value out mass ton, and this is printed. And then we get the total seismic marks. Now we are going to calculate the seismic base mirror using the Eurocode 8. For that, we have assumed our soil type, mhm, type type 1, which is highly seismic. We can show the table from Eurocode table 3.2, Eurocode 8. Table 3.2, 3.2, table 3.2. We have type 1 elastic response spectrum. We have defined at this soil type uh, D. Our soil type, for my assignment, it is D, and we get the all the value S, TB, TC, TD. You can see it. Yes, TB, TC, TD. Then the reference, and we have taken the ground excavation in 3 meter. I can show you that we got this one, and we got the soil type this one. For system, we have the peak ground excavation is 3 meter per second square, and importance factor for the building, for our building is 1, because mm, it is our residential building. We have taken 1, and we get the design ground excavation value, gamma into ag, 3 meters per meter per second square, and we can see the diagram of design spectrum, and this is the value 5 I have already shown you. And then after This is like where I get the value of phi, and this is the region where we get the value of categories of buildings. Then importance factor, we can see it's page 53 in Eurocode 8, ordinary building not building into other classes. Yeah, okay. Then we go for the steel. After that, we got everything like that. Now we go to the steel movement resistance frame, and we have that natural time period T1 C3 into S 0.75, and we where the CT value is 0.75 of steel. We can get it from Eurocode 8, page number 57. T7, we go to here, T7, 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 it is off. For the concrete masonry wall, the value of CT is 4.0.07. Still looking for what? Equation 3.19. Look, 0.085 movement resistance for steel frame. Here is the value. We got this value, and we got the value, and we have the height. We got the time period, and we here our time period is here TC is equal less than our time period is between TC and TD, which we have given in up, and we have as in the ductility class Q4, and then we get SQ. ST, and then base here we have lambda into m into ST. Time period less than 2 Tc, so our lambda is epsilon, and then we calculate the base here and the horizontal force, and we get the horizontal force by dividing the mm, total weight of the buildings, and then after we calculate load distribution and movement calculation, and it is done. It is also given in the Eurocode 4.3.2.3. We have the height, mass, we get the mass into mk, and force Fk is equal to Fp into Z 547.77 divided by 32,390.7 into 1000. We have assumed the force 1000. So the calculation here, this is this is one. This one is K3 by 32 by 54, 7 by 32 into 1000, and we get the value, and movement, we get the movement is also force into height, and here is the height, we get the 4761, and effective height H is equal to 94.45. If we need to calculate the effective movement or something else, then we can calculate it in like this: 19.45 into 1000 is equal to 94. We get 19,455 kilometer per meter, the movement. Similarly, we can calculate for the concrete movement resistant frame. We have the CT is 0.075, same process. Then we can calculate for durable system, and we get the force. And force, we have the force, this one force we get on the top, and we can calculate the total lateral force. Look, for steel it is 75955.04. How we get it? We can get it by 171.28 multiply by 3.47 4 kilonewton, we get it. And similarly for concrete 4.041, we multiply, we get the base shear, and then if we multiply by for durable by 4.980, we get the total latent force for roof. Yep, now we can show this one right here, 3.4. If we multiply by, look, this one into 3.47, we get the 95, and we calculate, we sum it and get our value. By this way, we can calculate the base shear and base moment of our buildings. Thank you for watching my video.